Again, this is our final session of the day, a final session of the conference. We're going to be talking about what's new in California's rubberized asphalt market. And I'm going to turn this over to my colleague, Lito Tamandong, Waste Management Engineer at CalRecycle, to moderate this session. And then after this concludes, I'm going to do a quick few minutes of wrap up so we can get you guys out of here and on the road. So, Lito, take it away.
Thank you, Kyle. Yeah, hello, everyone. How's everybody doing? We're at a home stretch, so this is the last session, like Kyle said, so we're saving the best for last. My name is Lito Tamandong, Waste Management Engineer with CalRecycle. The session is titled, What's New in California's Rubberized Asphalt Market? So in this session, we will explore current trends and new methodology to increase use of crumb rubber in California paving and preservation applications. The presenters from academia, local government, and industry will provide updates on research, technological advancements, potential market growth, and improvements in infrastructure. We will have 4 presentations lined up. The first will be manned by Scott Dimitro, Chief Operating Officer with Payment Aces, and Brandon Millar, Technical Director at CalAPA. They will be talking about improving California pavements with rubberized asphalt. They will be followed by Frank Frasciti, a Division Manager for City of San Jose's Transportation Department. He will be presenting long-term field performance of rubber-modified asphalt roads with cold-in-place recycle base. Then we will have James Signor, the Principal for Nichols Consulting Engineers, or NCE. He will be tag teaming with Theron Roshan, Municipal Service Manager for Plano West Consulting Group, to talk about the pelletized rubber demo project that will take place in Stanislaus County. And then last but not least, we will have Angel Mateos, Associate Research Engineer at UC Davis, UCPRC, or UC Pavement Research Center. He will be talking about the use of reclaimed asphalt pavement, or RAP, in rubberized hot mix asphalt gap graded, or RHMG. Before we get started, unlike the previous sessions, we will be taking 2 to 3 questions after each presentation. Then at the end, we will open it up for all 4. And just a reminder, for our virtual audience, you can ask questions using the Q&A widget. So without further ado, let's get started. Scott and Brandon?
Brandon. As you can see, there's a lot of us up here, and we're going to try to land this plane a lot more on time than some of our domestic carriers. So let's go ahead and start off. Once again, thank you, all of you, for being here and hanging out with us for the final session of this conference. We have a really good story to tell, all of us up here. And when we talk about recycling materials, we're always trying to figure out another way to get rid of it, right? And without having any negative impacts. Here's a story where we're actually utilizing it in something that everyone in this country uses and relies on every day, and it actually shows an improvement to those materials that are used in our roads. First off, my name is Brandon Millar. Scott's going to come up here in just a bit. I'm the technical director for the California Asphalt Pavement Association. And we represent asphalt stakeholders since about 1953 here in California on our roads, improving our roads, helping our industry and our stakeholders better understand how asphalt pavements can really help our communities grow and thrive. We do that through our strategic plan. And so promoting, learning, advocating, and networking, all about asphalt. So that's where we are. Yesterday when Richard was up here and was talking about EPDs, he and Amlan, one of the things that Richard's group, the National Asphalt Pavement Association, has done is really coalesce the industry around what are our sustainability goals as an industry. And so we've put together this national effort to really help our pavements, really help our industry meet our sustainability goals in all of our communities. And we know we can do this because, you know, for many of us, we're engineers. We are provided an opportunity to fix something, and we figure out a way to do it. And utilizing recycled materials in asphalt pavements, we can do it and we can show it. When we look at the state of California and we look at the pavements that we're dealing with, we first look at our population. We look at the numbers of vehicles registered, how many drivers we have, how far and how long people are in their vehicles. They're pretty staggering for when you look at this compared to the rest of the country. That's a lot of people in cars driving our roads every day, and we have a lot of roads. When you look up here, to give you an idea, it says, 15,000, Caltrans manages about 15,000 centerline miles. Another way to say that is they actually, about 13% of all the roads that are in California are overseen by Caltrans. That's about 52,000 lane miles, right? So there's a lot of roads up there. But when you look at us as a state, we're just under 400,000 lane miles in this state that we have to manage, we have to maintain, we have to repair. And that's number 2 in the country behind Texas, which is at about just under 700,000 lane miles. And then you have state like Hawaii, which has just under 10,000 lane miles. So you can see that from California, we've got a lot of what we in the asphalt industry like to say opportunities in front of us. So when we start to look at our industry, we do a lot of work out here to help build, maintain, reconstruct our pavements. A lot of tons of mix go down in this state. And probably one thing we look at is half of that is in private work, the other half is in public. So when you start to look at that breakdown in regards to lane miles, we said Caltrans is 52,000 miles. We're looking at cities, about 181,000 lane miles, and counties about 150,000 lane miles, more or less. All that private work, that's maybe some residential, that is parking lots, all of that type of paving. So that kind of gives you an idea of what we're dealing with here in California. So with some terminology, everyone calls it something different, depending on which city you're in, which state, which country. But just realize that in general, we start to coalesce around some general concepts in regards to asphalt rubber. We'll say asphalt rubber, we talk about having a minimum of 15% ground tire rubber in the mixture, 15% in the binder, which is in the mix. And then we also have other types of rubber binders and rubber additives also that we deal with. So how do we deal with it? We look at how do we improve our pavements, and we take advantage of the rubber particles to help improve the materials that we're using. We see that in our mix designs, our pavement designs, how we actually build it. We have to make some tweaks on all of that. But the key thing is that we're able to maximize the use of those ground wire timber and take full advantage of their performance benefits. Overall, we have a lot of tires here in California that we have to deal with, and it's been growing year by year. Why are we doing these tires? Hey, back in the 90s, we had huge stockpiles of tires in this state, and they would catch fire. We had 3 major fires in the 90s. What we don't often talk about is, we talk about what are we going to do. We've been talking about the coho, but this was a big one. Because anyone who lived in California remembers the black smokes that was coming out of these stockpile fires, and they wouldn't go away. And this is one of those art imitates life, where you had regular occurrences on our favorite cartoon show, The Simpsons, where they would always talk about the burning stockpile. And this was a running gag that went over for a good decade in those shows. We had to do something about it. And so that's really where we start to look at the commitment by our owners, by the agencies in regards to how are we going to manage these tires? How are we going to get rid of them? What other ways do we have? It led to 2 ways that that our owners in this state committed to use tires in this state. One was through a straight mandate, which is where the legislature said, Caltrans, you will use ground tire rubber in your pavements. And then we also had CalRecycle, who came in with more of, let's put the carrot in front of local agencies to use it. As a result of those, we've seen a significant increase in rubber. Doesn't mean there's not a lot of space to grow, but we have seen this steady increase in rubber usage. Here's for California. Here we start to see the actual comparison of asphalt rubber to conventional mix usage in California. I'm moving through these slides fast. You can download them off the website, so please do that. Here just gives you an idea. We're talking about 1.7 million passenger tire equivalents that Caltrans used just in 22 alone. And then also with the CalRecycle grant program, we're seeing another 2.6 million passenger tire equivalents that are being used each year because of their grant program. But that doesn't account for all of the other possible uses of it within our public works. So we're starting to see more increase in how we use it in our public works infrastructure projects. So how do we do it? Why do we do it? It's because of the performance. That's really what it comes down to. This material started back in the 60s and 70s and has moved over to the present time where we have seen its use. It's been played around on the streets in Southern California, in Arizona, all across the country. And the common thing that comes out of all of this is we're seeing something better than when we didn't have it in there. Great research that has come out from UC Pavement Research Center. We have our director for the UCPRC who's sitting right over there, John Harvey, going way back to 2000. Remember, we're talking about just after the fires, where we start looking at the performance of the asphalt rubber compared to conventional mixes. We start to look at heavy vehicle simulator testing at the test track at UCPRC, where we see here's the cracking pattern for our conventional mix. Then we go ahead and take asphalt rubber and we do it at only half the thickness. And it's actually even at half the thickness, it's even better than conventional mix at a full thickness. So we're starting to not just see it in the field, we're now at a point where our research is starting to quantify it. Quantifying the improvement to crack resistance of these mixes. We see it in more performance testing that we're moving to in our industry. For fatigue resistance, how it's much better than what we would typically see with the conventional mix. And when we're talking fatigue, this is about cracking, right? This is about where the pavement isn't cracking or taking longer to start cracking progression to failure. So continuing with research, Angel's going to come up here in a little bit and he'll really go into a lot more detail into it. Tire processing. How do we take this tire and make it into something we can use? Our friends here at CRM sitting over here, they've done a great job in regards to showing the industry, showing all of our agency partners on how we do that, how we take a tire, how we go ahead and grind those up, break it on down into smaller parts, take out the metal, how, we take out the fiber. We talked about that earlier in regards to the effects fiber can have in regards to our pavements or just any recycling use in general. And then we go ahead and put it out into different sizes. We have two primary processes, and when we talk about innovation in the asphalt rubber space, it's about looking at wet process innovation, right? We're currently using asphalt rubber where we take it really hot, we mix up the rubber in it. We also have something where it's terminal blended, right? This is where we start to look at the devulcanized rubber and utilizing that to modify our binders and our mixes. And so what are we actually, go back. What are we actually doing? We're finding a way to make that rubber particle that when we hold it, we can rub it in our fingers like a grain of sand. Doesn't feel like it can do it. We can go ahead and in our process meld that with our asphalt to take advantage of its resilient properties. We do that in heavy equipment at hot plants where we're actually doing this on a regular basis during our mix production. We can go ahead and take that binder that we've blended in the field, maybe the binder that's been blended with the crumb rubber at a terminal, and we're able to add it to our mixes. So we have more and more new technologies on how do we improve that? How do we improve getting the crumb rubber into our mixes? We also have our dry process, where this allows us to have different types of rubber pellets that we can add at the plant. So this is where that innovation comes in it's not just does it work, we know it works. How can we economize, how can we make it more efficient to get that crumb rubber into our mixes on an everyday? And then we evaluate it with our life cycle cost analysis, similar to what we saw LCA for local agencies. The City and County Pavement Improvement Center, which John Harvey is the director of, they provide a lot of insight and training in regards to how agencies can use an LCCA, the procedure to evaluate the different types of strategies to maintain and reconstruct pavements and make sure that they're making the best decision for our public utilities. Looking at the performance of the pavement. So we take the performance information we have from our research and from our field, we utilize that to choose the best treatment for our roads. And then we can compare them and make sure that this is cost effective. And that's one thing we definitely see with asphalt rubber is that when we do all of those calculations, we have a cost effective solution. We have different available LCCA apps to do this type of evaluation, whether it's through CCPIC, the Pavement Preservation Center at Chico, Road Resource, FHWA, all have great information on how to utilize these LCCAs. So with that, I'm going to bring up Scott. He's going to talk about using pavement preservation treatments that incorporate ground tire rubber. Scott?
So as we were preparing for this presentation, I looked at Brandon's 55 slides and I said, I'm going to have about 30 seconds. And he said, no, I'm going to blow right through that. And I said, well, okay, I'll find out when we get to the end. And congratulations, Brandon, you moved rapidly through that. I do want to say I appreciate I expected 4 people left in the room, 3 of them to check up on what I was doing, and one of them because they didn't know where they were and they thought there was going to be dinner served. But I appreciate everybody staying. There's actually more of you than there is panel, which I was shocked by. I'm going to start off where Brandon left off. One of the things that we look at in pavements all the time is pavement preservation versus rehab. What type of materials are we using? And this is actually from the Road Resource website that Brandon mentioned. It's just a comparison between 2 different approaches to treatments. Am I doing 2-inch mill and fills every 15 years, or am I doing something where I'm using products like an asphalt rubber cape seal in the middle of this after some slurry seal and some crack seal and some other things? And the idea here is to look at those life cycle over the cost of a 40-year road, 50-year road. How far can we push that out? How much can we save the owners? So this is the example with actual numbers in it to what Brandon talked about. As far as the technologies in use, we're not here to explain and delve into every one of those, but I'm just going to touch on the technologies that are being used in the state of California at this time with rubber in them. As far as I know, there are some folks out here who may have 1 or 2 more. Asphalt rubber chip seal, by far the workhorse of throughout the state. At city and county level, it is heavily used to seal the cracks and take care of the roads, and I'll show you that in a little bit. A little bit of rubber modified slurry and micro, and we'll talk about that. Rubberized crack sealant, you don't think about it very often, but there's anywhere from 2 to 10% ground tire rubber in every one of those little black squirrely lines you see out there on the road. And some of those are pretty wide and pretty deep. Latex innovations, there's some new things out there. Tire rubber modified slurry seal, and then I've got a couple other really interesting new things that I've heard about in the last couple of weeks. I just thought I'd throw in as a way to think about how we can use more of this ground tire rubber in this state and how we can get more of it diverted from the landfills. So with that thought process, I come back to Brandon's picture of the binder plant itself. We've got an asphalt tanker. It's bringing in fresh AC from a refinery. It's going into a heated tank. It's going through that blending unit, and then we've got a reaction vessel. This is how we make rubberized binder, whether it's going into a hot mix asphalt facility or whether it's going into a truck to be taken to an asphalt rubber chip seal job. And that's what I'm going to focus on here. So first of all, we pull that material out of those tanks. We put it in here into a blended tank, which has continuous movement in it because we cannot let that rubber settle. We take that out to the job site. We put it in the spreader unit, which you see here. And most of these have an odor control vehicle on the back of them. There's some way to draw those fumes in. There's some way to take those fumes and filter them to get the particulate out of the air. Air Resources Board has requirements on these jobs that you have to actually meet as you're spraying, because this material is typically sprayed at a little bit of a higher temperature. This just happens to be what the back of the truck looks like, and this is actually what the inside of that filtration unit looked like on this particular spreader. There's a bunch of different companies have come up with different innovative ways to take those fumes, draw them in, run them through, and filter them. So this is what the application looks like when it's going down. So we're spraying a hot applied binder here, and we're putting down 55 to 7/10 of a gallon per square yard. And you go, okay, you know, what's that mean to us overall? I'm going to get that really shortly. This is what the application looks like after it's down. It really looks like a very heavy application of, you know, I always called it kind of the liquid rubber band. You put it down on that road and it fills in some of the cracks, it covers over all that, and we put some rock on it. And after we do that, we roll it and we end up with a finished product, which is great. How many tires is that getting off our roads? That comes down to the question. And what's the benefit? First of all, these AR cape seals, AR chip seals, we've got them lasting anywhere from 10 years to 15 years. I've seen some that are lasting 18 to 20 years out there. Now, should they have another treatment on top of them? Yeah, they should at some point. Here's some interesting facts and data. This is my big fact data slide. Caltrans usage, 2021, 2022, 5,085 tons of asphalt rubber binder. So about 1,000 tons of ground tire rubber went into that process. 22, 23, they're down to 3,000 tons. We are trying to figure out what Caltrans is doing. Who here's from Caltrans? See, they're all over at Tom Pyle's retirement. Brandon and I went over there at lunch. 39 years, he's retiring. He's the guy we've been saying, why aren't we doing more asphalt rubber chip seals, Tom? He just decided to retire instead of answer the question. I don't know what's going on there. Cities and counties, however, in calendar year 2023, 12 to 15 million square yards of asphalt rubber chip seal, which is 40,000 tons of binder. As Brandon said, Caltrans only owns 12% of the roads. The cities and counties own the rest. They've got to find a way to maintain them at an economical perspective. So asphalt rubber chip seal, asphalt rubber cape seals, extremely economical, last them a long time, using 8,500 tons of ground tire rubber. And Barry, you can verify my numbers for me. I know I'm probably off by 12, 15 tons, and if there's anybody who knows I'm off by 12 tons, it's Barry. So, but that's 17 million pounds of ground tire rubber just being used in asphalt rubber chip seals. That's a lot of passenger tire equivalents right there, folks. And typically we cover that with a slurry or micro. Now, let's talk a little bit about slurry and micro. A couple of years ago, and probably 10, because the more I looked around that retirement seminar today, or this retirement party, I realized that he'd been there for 39 years. My wife's been with Caltrans for 38 years. And if they're that old, I'm probably forgetting how long I've been around. So bottom line is 10, 12 years ago, we did some terminal blended materials. We did that down through Central California. It was a material manufactured by a producer that left the state, unfortunately. We're not really using a lot of ground tire rubber and slurries and micros anymore, unfortunately. There's a couple little spot pockets down in the San Diego area where they're just putting in a little dry powderized rubber into the hoppers on the back of the trucks. And then there's a little bit more where there's a local plant that manufactures and sells to local cities who apply it themselves. This is an area that I think we could improve in this state. I think if we think about the innovations that are coming, if I think about some of the materials that are being developed by the manufacturers and the new products folks that are here, this is an area where we could expand our use of rubber by helping. The rubberized crack sealant I talked about a little earlier ago, 2 to 8%. Really, we're meeting a performance specification here. So if they don't have to put in filler, they don't put in filler. There are some other states, Georgia, Texas, for example, they're requiring in their crack sealants 10, 15%. I've heard one requiring 20% ground tire rubber in their crack sealants to make sure it's being used in that state, and they can still get the same performance requirements out of it. Here's a newer application. These are my couple of quick little innovation slides. I don't need names on them, but it's something new. Tire rubber modified surface sealer. This is basically a fog seal that has ground tire rubber in it. It's working really well. It's a little bit thicker application than we'd use with a standard emulsion. Just holding up well, and so far it's new. Again, new and innovative. I'm not saying long proven technologies. I'm saying new things we're thinking about. I found this one interesting. We're going to take the ground tire rubber, we're going to turn it into weed mats. They're going to put them around the guide rail posts so the weeds don't grow around the guide rails. Well, they're hard to cut with the mowers. You got to have people out there on foot. A great idea, stopping the weeds from growing, right? A weed mat, but we're using ground tire rubber to make it. And then there was this one. This one, it kind of blew my mind, but it's really interesting. Taking a wide crack, putting down a little layer of sealant at the bottom of it, filling it with ground tire rubber, and then sealing the top with another type of polymer. So basically, every time that concrete moves, the filler in the middle is like a rubberized sand. It just moves with it. It expands, it contracts. Instead of putting a cracked sealant down that's adhered to both sides and it pops off of one or it pulls off of the other, this moves with it. I thought these were interesting, innovative technologies that we're using in pavement preservation. I think we could do a lot more. I think I would urge CalRecycle to look at the new technologies that are out there and maybe open up the opportunities for some of these companies that started in another state maybe, but they have new technologies that we could use in some of our pavement preservation tools and techniques that we're trying to put in the roadways. And that's all I got. Thank you.
Yeah, thank you so much, Scott and Brandon. We'll be taking probably 2 to 3 questions.
Mine is not a question, but Traffic Devices is a company that does that weed barrier for us in California. So if you want an introduction, I'll make it.
Thank you, Denise. I just found it interesting when I was looking.
I just want to commend you, Scott, for getting off from behind that speaker's table. I've never seen a shorter presentation from you.
I'm getting older. I can't stand up that long, Skip.
All right. All right. So let's have Frank over here.
You got a high bar.
Hello, everyone. Just wanted to first thank CalRecycle and organizers for this very well-organized conference for all of us. My name is Frank Farshidi, with City of San Jose. I'm here to share our story of usage of asphalt rubber with you all. Title of my presentation is Long-Term Field Performance of rubber modified roads with combination of cold in-place recycled base in San Jose. The outline of the presentation, I'm going to talk about some of the definition and backgrounds, just for some of you, because this is a pretty diverse audience, and then I'll have some real field examples. We just hit the 10-year mark. We've been using asphalt rubber in San Jose for a long time, and we wanted to just take a look at the historical, some of our performance data that we have been collecting for the past 10 plus years, and see how this product is really performing in the field with different applications that we've been using. So let's look into it. Basic definitions of what we call RMA or rubberized asphalt or RHMA. So they all mean the same thing in California and in San Jose. So it's used in a gap gradation products. We call it gap graded or RHMA-G. It could also be used as a open graded mix, where you have a much higher interconnected air voids where the water goes freely through it. We don't use that product in San Jose. Our focus is mainly on the RHMA-G. Our usage has been. The The rubber comes from recycled tires, both from cars and trucks, and pavements that we've been using. As a lot of people already talked about this, the product is more crack resilient, and it also provides a smoother ride and a quieter road for our users, which our community really likes and appreciates as well. And we have received feedback from them regarding that. So if we were to get into the details of the mix design of this product, so it's a combination of virgin asphalt binder, crumb rubber, asphalt modifiers, and on the CRM, it's mainly 75% from scrap tires from passenger cars and 25% high natural from truck tires. How do we do the mix design for these RHMAGs or RMA roads? The current practice is the standard specification using the super pave mix design. Our specification, we designed these in the lab for 4% air voids using the gyratory compactor. And the gradation, as I mentioned, is gap gradation. So with the current process that we have, it's the wet process, so the crumb rubber is visible, it's not dissolved, you can still see it, the chunks of rubber are still there, so you need to accommodate that with the mix design. So that's why we use the gap gradation to accommodate that, and that's what we have. Now, what's a typical mix design look like? So this is an example that I'm showing on this slide, just to give you an idea what details of the mix design are like. We typically use it in a 2-inch thickness on our overlays. We currently don't have any wrap, and I think that's pretty much statewide. Still, we don't use recycled asphalt pavements in RHMAs. The binder content, we have a minimum binder content on this mix of 7.5 by total weight of the mix. And if you just do the math, and I've done that just to simplify it for you, the virgin binder portion of the RHMAGs are 6.1. So just keep that number in mind, because I want to compare that to the HMA mixes that we also do. So as I said, the gradation is gap gradation, but we have a significantly higher virgin binder that we are able to use with these mixes because of the rubberized component of it. So this is a typical mix design that we get on our conventional conventional HMA, right? So HMA is used everywhere in the nation, and also widely used everywhere else. Same mix, half-inch. It's a half-inch mix. We allow for up 15% wrap currently in our HMA mixes. The typical binder content is 5.1. So in this example, and this is just one for one job, but usually it ranges from 5.1 to 5.25. I haven't seen it anything higher than that. So as a comparison to the RHMA, so we're talking 1% higher virgin binder, and for the pavement engineers in the room, if you're able to increase that binder content on the film thickness around your aggregates, that's where your durability comes in, and that's why you would get better longer term performance out of your pavements. Now, how do we use these two products as tools in our toolbox? We mainly focus using RHMA on major arterials and collectors, and 1/3 of our network, our network is 4,300 lane miles of streets. 1/3 of it is arterials and collectors. These are the streets that carry most of 87% of our traffic. So think of higher traffic, a lot of buses, a lot of also trucks that travel. So we use RHMA on those type of roads. On the other hand, HMA on the residential side, we use the HMA on the residential side, and we would like to extend using RHMA because we have been getting good performance, but unfortunately the constructability and the limited uses in residential cul-de-sac areas with the gap gradation mix design is a limiting factor for us. And I'll talk about that a little bit later as well. Historical usage in San Jose. So again, we just went back 10 years just to have that perspective of our usage. This is going to 2014, and as you can see, we have been using more and more every year, and our program has expanded throughout the year. So back in 2014, also our pavement condition was in a pretty bad shape. We were barely hitting 60 PCI on the PCI, and I'll talk about that as well. But currently, as of last year, so these are, I don't have the 24 numbers here, 2023, we've used 93,000 tons of RHMA. So that's about a third of our usage. So like I said, we also do a lot of paving on our residential areas as well. Cost-wise, RHMA historically has been a little bit more expensive to HMA, and the gap, we've seen that gap increasing in the recent years. And I want to touch base on this a little bit later as well, but these are just some typical numbers that we received in 2024 that was kind of alarming to us. And I want to discuss this a little bit in the further slides. And we did a little bit of deeper dive to understand, well, 10 to 15% was increase cost on the RHMA was typical, but this year we saw a doubling of that number. So we've seen 33% more expensive in our 2024 numbers. We just another note is to keep in mind is 15% of our HMA mixes contain wrap, so they contain up to 15% wrap, but we don't think that increase in cost is because of the wrap, just an FYI, because it is still a very small percentage to contribute to this big increase that we've seen. Let's go back to the pavement condition index that I mentioned. So the PCI number is something that local agencies, cities and counties, both statewide and nationwide, use. It varies from 0 to 100. So 100, brand new pavement, 0 is completely failed, all cracked up, pretty oxidized and aged. The other tool that we also use in our pavement management is cold in place recycling. And we've been using that also going back to 2013, 2014, is where we go down and we pulverize the existing material up to 6 inches in place, and we add a little bit of asphalt. We use the foam technology, which adds a little bit of asphalt, 2 to 2.5% asphalt binder, and 1% cement, and it pulverizes that existing material as a base for your overlay, whether you want to do RHMA or conventional HMA. Now, we like this strategy because it provides a very good solid base, and it also is very environmentally friendly. You don't have to haul trucks in and out. You mobilize this machine or train, recycling train, where you're able to recycle that material in place and open it to traffic at the end of the construction or at the end of the day. For the long-term performance of these treatments, we wanted to just make sure we are comparing everything equally to each other. So we looked at our mill and fill practice as well as CIR and overlay. So we looked at mill and fill with HMA, mill and fill with RHMA, and then CIR and HMA and CIR and RHMA. Now, for those of you who have not seen a CIR operation, so it's a train. You have multiple machinery that you need to mobilize. You still, it looks like a paving operation because the last machine is a paver. After the material gets pulverized in place, it gets dumped inside the paver hopper and it gets put in place. And same type of effort for compacting it. So this is a typical CIR operation that we had on Coyote Road near Center Road. Now, let's look at some of the pictures and some of the field data. So I'm showing just the RHMA field performance because this is for the sake of this presentation. But all the streets that I'm showing here, they are all major arterials. They carry heavy traffic index of 10 and above on these streets. So this is a picture of Mayberry Road. It was last paved with RHMA in 2010. So it's been a little over 14 years now. So the treatment that we did back then, it was a mill and fill job with 2-inch mill and 2-inch fill. The current PCI as of 2023 that we did the inspection with the automated machine that we use through a consultant that goes out and takes videos and pictures of the road, and also it has a laser in the back that analyzes and puts everything together in that aggregated PCI index that I mentioned, is 73. So think about the performance, 14 years, that's pretty good. And the picture also speaks on itself. That speaks 1,000 words, right? So we don't really have a lot of load-related cracks at all. We have mainly little damage, mainly oxidative block cracks. As a reminder, we don't design pavements to last forever. The typical design life is 20 years. And oxidative aging is something that happens from the environment because of the sun exposure that we have. And in San Jose, we have over 300 days of sunshine. So we're pretty happy. So, again, some more pictures of how the pavement looks like. As you can see, these cracks are they're not on the wheel path or anything. It's mainly oxidative aging cracks. Another road that we also looked at was White Road. So this one also was paved in 2010, the mill and fill. The PCI on this one was a little lower. So the current PCI is 61. Traffic-wise, I would say both of these roads carry the same amount of traffic. We are planning to seal this as a pavement preservation in this year, actually, as we speak. Again, on this one, same thing, limit load-related. So we had some load-related cracks on this road, and also same oxidative aging. So this is a typical picture that we got in the field on this one. As you can see, some load-related as underneath the wheel path. Foxworthy, that's another street that was in a pretty bad shape when we did this back to 2010. The PCI, the current PCI again is 72, and some pictures of that. And as you can see on this one, we have a longitudinal joint and some block cracks. So the longitudinal joint is something that we, it's definitely related to construction, and the contractor not being able to compact that joint very properly. Poughkeepsie, so now switching gears, so the streets that you saw up to now, they were all mill and fill jobs. Now let's look at some of these, the combination of CIR and HMA, or in this case, CIR and RHMA. So this street was done in 2012. So we did cold-in-place recycling with foamed asphalt with 4 inches, I think. I have to check. I think it was either 4 or 6 inches, but we capped it with 2 inch of rubber, a thin overlay on top. Now the current PCI on this street, as of an inspection that we did last year, is 92. So this was very surprising to us because we were really pleasantly surprised because it is holding up very well. Again, it has high traffic. We saw little to none of non-cracking, mainly transverse type of oxidative. Again, oxidative cracking, aging cracking is there. And keep in mind, this street was built a little later than the other two. But still, the street is in still a very good shape after 10 years. Monterey Road, so this actually is another major street. So this used to be a highway. Caltrans used to own it, and at some point they relinquished and gave it to the city to maintain, to operate and maintain. It goes from Blossom Hill to Flintville, this particular segment. Again, very high traffic. It was lastly paved in 2011 with the same strategy with CIR and RHMA on top. Current PCI is 80. Again, the traffic is definitely a lot higher than the other street that I was showing you, but still, we very happy with the field performance. Again, due to the, we have, so as you can see, the longitudinal joint is still a problem there, and as you can see, after those many years, 13 years, we are seeing that longitudinal joint opening up a little bit further, but still very good quality, right quality. Some oxidative edge cracking, but still in a pretty good shape. And some more pictures of that. Now, going back to the CIR and RHMA, we believe that the difference that we are seeing in the results in the field, the better performance that we have with the combination of two is definitely it has to do with the base. So if you are able to provide a solid base underneath these overlays, you can definitely extend that life even further and make sure that your pavements they stay smoother for a longer time. Now, those were just some examples that I provided, but we also aggregated the data. We looked at some of the statistical of the data that we have, and we wanted to focus on the PCI because it is a metric that our policymakers understand. Our community also is pretty well educated with this, and we also use it all the time for our pavement management system. So the drop in the PCI, so comparing just CIR and HMA versus CIR and RHMA, because we wanted to look at same strategy. With the RHMA, we definitely see the less drop, which is a good thing that you want, right? So you can see in that number that's roughly a 25% better performance that you get from rubberized material. Same base, so in both of these cases, you have a solid CIR base. So it definitely has to do with the overlay material and the material that you have on the top. Same thickness on the overlay as well. Average current PCI, so we couldn't really just have all of those years exactly the same. So as you can see, the HMA is 3 years, it's from 2015 versus 2012. So the average current PCI comparison was not the right metric, but the PCI drop per year definitely saw that. Now, if you remember, I talked about that increase in prices that we saw there recently in this year in 2024 from our bids. We wanted to do a deeper dive, and we surveyed some of our producers, our local producers that make both HMA and RHMA, because we thought, well, maybe this cost of material has increased that much that we're seeing that 35% increase. And we actually found out that's not the case, right? So as you can see in these numbers, so these are the numbers that we received from, typical numbers from some of the suppliers that we were able to average out. Cost of rocks and aggregates, pretty much on the RHMA and HMA is very similar. On RHMA is a little bit higher because you have that gap gradation that they have to meet. So $55 per ton versus $65. Asphalt binder price, asphalt binder is the most expensive component. We use just 5 to 6%, but it's pretty expensive, as you can see. Price of, and it's correlated to the price of crude oil. At $477 on both cases. In the HMA case, we only use 5.1%, and RHMA, because of that whole gap gradation that we have to use higher binder content, and it also gives us good durability. Is 6.1. CRM, or the crumb rubber, that cost is also there. It's only 1.1% of total weight of your mix in the RHMA. You don't have that cost for your HMA, but you also have the wrap cost for your HMA mixes. Now, overall, the price is $92 per ton versus $75 or $76. Now, let's look at some of the recent numbers that we saw, right? So back, as you can see in this graph, going back to 2020, that's where everything was a lot expensive. We were able actually to do a lot of projects at reduced cost because of the favorable economic conditions back then. But throughout time, things have increased. But as you see, the gap is increasing quite a bit, at least for our area. We also wanted to look at the crude oil and make sure that we're not missing anything there. So the highest price that we have seen, this is an index that Caltrans publishes and monitors. So as you all remember, 2020, that's when oil went negative. So that was the lowest price that we also saw for asphalt prices. And the highest that we've seen is from 2 years ago. It was 646. The price is stabilized, but what we are able to actually conclude is our increase in cost is mainly driven from the contractors. Right? So the contractors are giving us a little bit more increases in the prices on the RHMA, and most of them are still experienced. So we're still trying to put our head around that, because we want to use RHMA, but that increase in costs is and the initial is affecting our ability to do more roads. Now, on the conclusion, definitely we saw the improvement between the CIR and non-CIR treatment in both HMA and RHMA, but in terms of RHMA, we also saw the increase in durability because of that rubberized material that we have. We also believe, in San Jose, we've been doing CIR for a long time, and we believe that providing a homogeneous platform underneath overlays, whether it's for private or public roads, is very important. I'll finish it with just some opportunities that we believe is still needed for our industry, is to focus on engineering properties. Now we have the tools that we didn't have 20, 30 years ago when RHMA-G was invented. We have, for example, balanced mix design and better tests to measure those properties. Ideal CT is one of them. We could also look at engineering properties of asphalt binder that we couldn't do. And our specification definitely needs to be looked at and revised to be up to par with those. Now with that, I'll conclude my presentation. Thank you.
Okay. Thank you so much, Frank. So we'll be taking maybe a question from the floor or virtual.
Frank, have you considered using an RHMA on your side streets that you say you're now using standard HMA on?
We like I said, we would really want to use it, but there's no mixed design guidelines or any on the dense, using rubberized asphalt with dense mixes is not.
I was only introduced to it a couple of years ago. Currently have around 10,000 tons down of an RHMA dense grade. And the mix was designed by A-Part down in Shafter. And it's performing very well. Works in cul-de-sacs, works in tight places. We've paved parking lots with it. It's a whole different ballgame. Things you can't do with a gap-graded mix.
I agree. I think there is definitely opportunity, and just like us, other cities I think are on the same page. Most of their roads are on the residential, and paving with rubber, the current RHMA-G in residential is very difficult. We just, the workers don't like it, the contractors don't like it, and you can't really work with it and with.
No, you're being too kind. It's not difficult, it's impossible.
Yeah.
We have one more.
We can take one.
Frank, one of the things we've seen, particularly with counties and some cities, is the old R-value design method has this kind of archival thing in it that 40% of, I'm getting detailed here, 40% of the cross-section gravel equivalent has to be in the asphalt. But you're building a big, thick, full-depth recycling, and then you're putting big, thick asphalt on top. When we run CalMe for Caltrans, and we look at rubber on top, we only see the need for maybe 2 inches, 3 inches, instead of 6 inches that the old R value is requiring. Any thoughts or experience on, we're putting a catalog out for CalMe designs for local government, and it's, right now it has very thin rubber instead of big, thick HMA on it. Any thoughts or experience on that? Using the thinner layers, the thinner layers like you used here, but on full depth recycling.
Yeah, so we typically design, when we do our design, we do FWD, we do deflection testing, and we look at, like you said, going with a thick aggregate base or overhauling everything, reconstruction. And every time we do that analysis, CIR, cold in place, or FDR comes out ahead, both from life cycle cost analysis and also in terms of cost, initial cost for us. It is less expensive, and it provides that better base that you don't have to put a thick overlay like you mentioned on the top. Yeah, we are using the maximum 2 inches, and the reason we could go a little thinner in some areas and some streets, but we don't want to go to the method spec, and then that's going to cause all kinds of issues with our compaction, because we have a pretty tight compaction specification. We need to stay above 1.8.
All right. We're actually halfway, so we'll keep moving along. But feel free to get up, stretch, get a snack. So next we have Theron and James, and I think Theron is going to be first.
Good afternoon. My name is Theron Roshan. I'm with Interwest Consulting, but in a prior life, I was the chief engineer for Sacramento County, served them for 23 years, and we did our first asphalt rubber job in 1989. I had hair back then. We were not as sophisticated at the county than Frank and his team, I'll just say that, but got into using asphalt rubber because of less maintenance, and I think your statistics bore that out. I've been involved with CalRecycle for over a decade, where we provide at no cost to public agencies, to the grantees, training seminars. We have offer them an inspector for the first day's paving, not talking to the contractor, but there is a resource for the public agency. We've developed a specification template for asphalt rubber that looks to Caltrans but doesn't bring in all of the onerous requirements of a Caltrans bid, so we've developed this template. We've also developed a guidebook that's available for them. And then also on our team, we can review the mixed design submittals from the contractor just to make sure that you're getting compliance there. And I think I've trained over 180 agencies about asphalt rubber in my career. So you've seen a lot today, but I'll just summarize again. The motivation is less maintenance. Oftentimes, a project is funded through a grant or some other outside source, but the day-to-day maintenance falls to the gas tax revenues that an agency gets. So that's very flat, and so if you can defer maintenance or have less maintenance, that's a good thing. And I'll skip through some of the performance aspects of it. We've talked about life cycle and reflective cracking, but it's a quieter pavement. Not only smoother, but quieter. And we've done some studies about that. And that noise reduction compared to conventional lasts long past 5-6 years. So that's a nice little feature. Also environmentally friendly. We are using the recycled tires. And this technology has been around for 40 years. You've seen this exhibit before where you have to mobilize this blender equipment to the hot plant that's making asphalt rubber. That's a very costly endeavor. And so right out of the gate, even though you saw the statistics about asphalt rubber costs being higher than conventional, you have to absorb that mobilization cost. We did a study a while back where we looked at bid prices, and in the LA area, there's so much market demand for asphalt rubber that these blender units are permanently parked at the hot plant. So as a result of that, this study showed that asphalt rubber prices in the LA basin are significantly lower than the rest of the state. As a result of that study, CalRecycle adjusted the reimbursement rate under their grant programs. In the geographic area of LA, it's a lesser reimbursement, $10 a ton. The rest of the state, $20 a ton. So looking at the market in California with asphalt rubber, we talked about the LA area being pretty well established. The rest of the state, there's not a lot of asphalt rubber use in rural areas throughout the state. And part of that is that mobilization of that blender unit to those rural areas. Also, rural areas may not have a lot of budget for a project, and so you get a smaller tonnage job of asphalt rubber. And so the thought here was, is there technologies out there that can alleviate that mobilization of that blender unit? And there are. So these new technologies that are out, currently not made in California, they pre-blend the crumb rubber and liquid asphalt at a refinery or somewhere else. And then they're shipped to the hot plant cold. And then they get introduced into the hot mix as it's being made. And the claim is that the performance is going to be equivalent. So CalRecycle wants to study that. So what they did was they partnered with Stanislaus County, and Stanislaus County has currently an awarded project that will be under construction in the coming weeks. It's 3 miles long. It's using 6 different products in the overlay. 4 of those products are rubber. So we have a section that is the traditional asphalt rubber hot mix with the mobilized blender unit. And then we have 3 test sections that have pre-blended these smart mix, pellet pave, and Asphalt. So these are going to be placed this summer. CalRecycle provided $715,000 to Stanislaus County to do this test project and also document the test and monitor this section over time. The CalRecycle solicited letters of interest. They received several of them, and Stanislaus County was selected. These test sections will be compared to a conventional asphalt as well. So side by side, we'll be able to monitor pavement performance over time. And then we're going to document this material, do wide outreach so that transparently everyone can kind of see the performance of this project. There'll be some interim announcements of probably documenting how it's placed and things like that. On our team, we have the Prime, which is Nichols Engineering, Mike Robinson, who is a well-known pavement expert, and then with the Inner West staff. Together, we did pre-overlay evaluations of the pavement. We did the design of the overlay, and then we're going to be conducting the field observations for that long-term documentation. Stanislaus County stepped up in a leadership role too and grew the size of the project. They added $1.4 million of local funds to extend the project limits to try to capture an economy of scale on the project. So there are 3,700 tons of traditional asphalt rubber with the field blended. There's 1,500 tons of a product called fiber reinforced asphalt. Little fibers get pushed into the mix and helps interrupt the stresses there. And then the county is paying for the base repairs and the final striping. So we have bid results. So let's walk through this. So the 3 test products, pellet pave, smart mix, and Asphalt, are on the top here. And the asterisk is that these are California tires because we're using a CalRecycle grant. So they had to get California tires, ship them back to I think one's in Michigan and one's in Texas, and then make the product and ship it back. So a very important asterisk on these prices. So the pellet pave was $250 per ton. They're placing 542 tons. Smart mix, $224 a ton, same tonnage amount. And the EcoFart, $260 a ton for the 542. Now, the conventional test section is 650 tons, and that came in at $126. So there's a big, delta there. And then the traditional asphalt rubber hot mix came in at $137 a ton. A larger quantity, we're placing 3,700 tons. And then the fiber, about $144. We also asked in the bid to, kind of what Frank went through, to open up what is the pricing for all the constituent materials that go into that per ton bid. So we got costs for the mix design, mobilization, aggregate, binder, producing the material, and then the mix haul and placement. So we have all that data as well. So with that, I'm going to turn it over to James Signori to kind of take us to the next steps that we're going to go through.
Yeah, hi, everybody. My name is James Signori with NCE. I'm basically going to tell you about the same things that Theron has already said, but maybe with just a little bit of a different angle. And so, when I think back about the last 10 years of being a pavement consultant here in California, I probably talked to 100, 150 different agencies. And I tend to get maybe 4 different spins when I talk to people. One is, I love rubber, I want to continue using it. The other is, I hate it, I will never use it. And that's primarily because they had one bad experience at an agency 20 years ago, something like that. And they're tough. And then you've got the person that, I've never even heard of it, so you get the chance to educate. And then the fourth one is, I'm willing to listen. And so I'd like to thank CalRecycle and the county for giving us the chance to build this test track, because, no matter how much evidence I've got, I could pull out Professor Harvey's studies, show them all sorts of things about how well these pavements can perform. But if someone has had bad experience, or if they're a little uncertain, or if they're nervous about, or if they're risk averse, what have you, they don't want to try anything new, sometimes they have to experience it themselves. And I think seeing this test pavement in action, and we're going to invite lots of people to be able to check it out during construction and then following construction. So the basic steps, site map and plan, we'll talk about some of the materials, monitoring and so forth. So here's where it is. It's down in Keys, California, just north of Turlock. As Theron was saying, it's a 3-mile section with 6 different asphalt pavements. I can't tell you how many times I've talked to clients and have asked them when they're doing their yearly programs, build some sections with slightly different materials to see if one works better than the other, as opposed to just trying to guess. And here's a chance to finally get to do it. So you've got the rack, or the RHMA-G material. You've got the short test sections in the middle with the rubberized materials plus the asphalt control, and then a fiberized on the eastern end. This is what the section looks like in terms of PCI. For those of you that are familiar with the PCI, Pavement Condition Index, basically it's a reference from 0 to 100. It's not a perfect metric of condition, but if you've got, these pavements are, 66, 64, 54, 57, they're reasonably consistent in condition, level of cracking, and so forth. They do all have some pretty serious rutting at the intersections. This is a high traffic, heavy traffic corridor. And so let me show you some of the pictures to give you a feel for what it looks like. So you can see that pretty extensive cracking throughout, a lot of cracking between the various lanes or where the adjacent poles of asphalt happened. Heavy truck traffic. This is a farming area, especially in the farming season. One of the goals of this project is to build it before the, what, Mustafa? Before the season, before they start hauling the fruit and vegetables from the, exactly. So We had to get in there, and the goal is to get it built ahead of time. One of the toughest days I could remember was being out there with about 6 cans of paint, marking the base repairs, dodging 60-mile-an-hour traffic. And the point is, while the sections are reasonably even, the goal was we didn't have a huge budget to literally try to make them all the same. This isn't a pure research study as such. You know, we didn't have that ability to make every section equal, but through marking the repairs and fixing the cracked sections, we wanted to at least be able to make them semi-equivalent. And so the contractor's first step is to go out there and fix the pavement. And what was going to happen is we're going to document a lot of this ahead of time. So we have Chico State coming down to fly drones to document the condition before the pavement is repaired, after it's been repaired with the patching, and then we'll get some work done during and after. Professor Harvey may have some folks come and sample, maybe. We haven't figured it all out yet. It's still happening. But anyway, it's really exciting. I can't wait to get this started. There's 3 separate materials that we're going to be using, so that are what we would call equivalent to what would be a terminal blend in the old school language. We have the gap-graded rubber that we've been talking about here, which is the wet process. The rubber is melted into the liquid asphalt and then blended in. In this case, the rubber is converted through various chemical processes, all of which are proprietary, so I don't know the exact methods, but this Smart Mix, Pellet Pave, and Eckerfault that you'll see here, they're all similar in kind in the sense that they've pre-blended the asphalt with the rubber, cooled it, chopped it into pieces of different grades, and then sometimes they'll put a surface coating on it to make it more free-flowing so that it doesn't clump up and stick together. And so these are entered in at the plant. They're put in at the wrap collar where you put in wrap, so it actually enters in and mixes in with the hot asphalt and binder. So it's a lot easier than trying to bring in the blender unit that Theron was talking about. And the idea here is that because it's difficult to get the technology, the wet process, the gap in more remote areas, we're looking at ways to maybe, how can we bring this material to more remote areas or even local agencies that just want to try it. So the schedule is as follows. You can see the board's already approved it. We're past that. Construction's already kicked off and the working days have started. So the countdown begins. Right now, the contractor is doing the mix designs. They'll get that all set up and get that ready. And then over the next 6, 7, 8 weeks, we'll get the construction completed, probably end of July, early August. So you don't be surprised if you start hearing about this project around. We're going to publicize it to make sure it's out there, and the details will be determined. As far as construction monitoring, as I was saying earlier, the idea of using drones in a field survey so we know what's out there. We're not doing an official tracking of condition over time. It may be to some extent, but it's not as if we're doing a hardcore research study. But nonetheless, I think we'll be able to show that these materials work. It's not that we're trying to prove that one works better than the other and the other. We're not trying to do a ranking or anything like that because we don't have it set up that way. We're trying to show basically yes or no. Can we use these materials or not? How viable are they? And I think this experiment should go a long way. So we'll be doing a lot of observation during construction, inspection, and testing of each of the materials. A lot of documentation, because part of this is we want to end up with a report that is justifiable and defensible that says these materials worked as such. Once we get that unbiased report, present that, and then we'll be in good shape. So anyway, stay tuned for this. You'll start probably seeing it in the next few weeks as construction begins. And while we're talking about that, just a little bit of other work that CalRecycle is doing as far as asphalt and pavements. And one of those is we're looking at updating the Rubberized grant program. Theron mentioned a few minutes ago about the difference in cost between rubber in Southern Cal and Northern California. That information was based on a study that he had done a number of years ago. We're now updating those numbers with data up to and including 2023, 24 numbers, and that should be done in the next couple months, hopefully, and we'll have that out. Also, we're looking at seeing if the rubber curves or deterioration curves within the pavement management systems could potentially be altered. Basically, the pavement management systems you see, the street savers, the pavers, et cetera, they have deterioration curves which say the pavement is this good at year 0, this good at year 10, this good at year 20. How calibrated are they? How accurate are they? And so we're looking at all the performance data around the state from Caltrans, local agencies, and so forth, and trying to identify whether those curves need to be modified based on current conditions. So that should be out in the next few months as well. So with that, I think we're done, and I'll pass it on to Angel, or questions?
Yes.
Okay. All right.
Thank you so much, James and Theron. We'll be taking questions at this point.
Steve Krause with CRM. I had a couple of questions. Actually, the first one is more of a statement. The premise behind the pellet project is trying to utilize the pellet material in so-called rural areas. But, asphalt rubber is being used all over the state. It's being used in areas like Eureka, Fortuna, upstate Northern California, as well as areas out Redding, east areas like Alturas, Bernie. So asphalt rubber is frequently used all over the state. So I want to make sure that people understand that. One of the other questions I had is typically CalRecycle, most projects that they incentivize or provide grants for, there's a requirement that it's California tires processed and manufactured, the crumb rubbers processed and manufactured in California. This particular contract, I believe, deviates from that requirement. So that's the requirement of the grant program, or the RAC program, the TIP program, tire derived product program. But this particular contract is a little different, where this requires California, the use of California tires. So I guess my question would be, what documentation or process did you use to ensure the chain of custody that California tires were in fact used to produce these materials, shipped back to California and utilized for this project?
In the bid documents, we inserted the CalRecycle form where the contractor has to certify that California tires are used, and there's a manifest process behind that. So we have that documentation.
And also, I just want to add also, you alluded that, typical grants for CalRecycle, they require the tires to be California tires and processed in California. This is not a grant. This is a contract, and contracts usually always require to be Californian tires, and it doesn't say anywhere in the contract that we have with the Stanislaus County, the tires has to be processed in California.
I guess one of the other things that maybe that I would be interested to understand is, or actually to follow up on obviously the three pelleted products are proprietary products. A lot of times with, whether it be chip seal jobs, especially with state agencies, whether it be counties or cities, they have to supply rubber submittals, they have to supply SDS forms, as well as certificates of compliance that provide gradation, they provide chemical composition. What type of documentation is being required of these proprietary products that are similar to what California contractors have to provide for the local agencies when they perform their jobs, whether it be a chip seal job, Cape Seal, or rubberized hot mix overlay?
I don't think there's any difference. We use the standard county specifications referring to submittal requirements. All of that's public information, so if If you want to reach out to me, I can send you the specifications and we haven't got a mixed design submittal yet, but that would be part of it as well.
Yes.
And lastly, I guess one of the questions I would have is, maybe you guys can walk through kind of the QA, QC, and post-construction performance testing that will be done on this project, and how does that compare to, like, for example, the pilot projects that are done at Caltrans, or that, for example, maybe the UCPRC undergoes and tests. What is how is the rigor of this post-construction review going to be compared to those types of projects?
It will be just exactly how we do any other project. James and, Terran could speak as well, but it's just going to be the normal Q&A, QC that we do any other projects that we do out there in the state.
I'll just say that the county isn't as financially robust as the state to do everything a state project would do.
Okay. Is there any more questions? Oh, all right. Thank you, guys. Hey, we're down to the last one. All right, Angel. Take it.
Okay, good afternoon, everybody. Thank you for being here. Second day, afternoon, last session, last presentation. So thank you very much. My name is Angel Mateos. I work for the University of California Paving Research Center. I work in UC Berkeley. The University of California Paving Research Center, what we call UCPRC, has facilities in Davis and Berkeley. The director of the center, who is John Harvey, is in Davis, but we're a relatively small group of people working in Berkeley. Before beginning the presentation, of course, I want to acknowledge my co-authors and all the people that have been involved in developing this study, including Professor John Harvey, who is the director of the center, Jess Bushek, who is with us today. He's the UC Davis laboratory manager, Brielle Moreno, who was with us a few minutes ago. She's a research and development engineer at UC Davis, Irwin Wada, who is at UC Berkeley, Tanugna Maralapu, who is a PhD student, and I'm sure I'm forgetting some more people, but there have been many people involved in the development of this study. And of course, I would like to, what am I doing?
Green button.
Now, I would like to give a special thanks to our sponsors, including CalRecycle, Waste Tire Recycling Management Program, and in particular to Mustafa Botan, Matt Weiss, and Lito Tamondon. Thank you very much for supporting this research. Of course, thank you to Caltrans Office of Asphalt Paving and the paving program in general, who are also supporting this research. And thank you to Caltrans PMPC group. And I'll tell you what the PMPC group is, in case you are not familiar with that. I mean, the PMPC group is a joint effort between Caltrans and industry that is created to address very specific problems. Like in this particular case, the problem that the group tried to address is the answer to a very simple question is, can we add RAP, reclaimed asphalt pavement, to the RHMAG? Yes or no? And how do we do that? So that's the question that the PMPC group tried to address. So that is a PMPC group that was created, that has people from Caltrans, people from industry. They developed a working plan, and the UCPRC was tasked with supporting that group. That's why we have been doing this research. Before we start the presentation, I have included a slide here to show what is RHMAG. I am aware that there are people from different countries here that I'm positive have never heard of RHMAG. I know we have at least people from Honduras, Mexico, France, Switzerland, and maybe other nationalities. I would like to ask, how many of you have heard the word RHMAG for the first time? Quite a few, not a lot, but quite a few. I think my previous presenters have introduced the idea of the RHMAG very well. Just let me emphasize the idea of the gap gradation. What you see on the screen on the right is a grading plot where you have the aggregate size. You see in green the HMA, right? You see that is what we call a continuous gradation, which is a dense gradation. Thus, we have the HMA, as you see in the picture on the left, has all of the aggregate size. And the issue with that is that you come out with a very dense gradation that has very little voids. And what is the problem with that? The problem with that is that there is no room to introduce the crown rubber. And here, when we are talking of crown rubber, we are talking of particles that are millimetric size, in the order of 0.1 inches and below, 2.4 millimeters and below. So those are relatively big particles when it comes to introducing them in the HMA, right? So that's the idea of the gap gradation. With the gap gradation, what you do is you get rid of the aggregates or many of the aggregates that are below that size, below 0.1 inch. So you create a space, and that is the space when you introduce the rubber, right? That is the idea of the RHMAG. The next question is, why do we need RHMAG? And again, my previous presenters have done an excellent job in saying that the RHMAG is worth it, that the performance is very good. In this introduction, I'm going to give you just a few numbers. Okay, if I'm going to build the RHMAG, if I look at Caltrans 2022 crown rubber report, I see the average number. I see that the RHMAG is, on average, or was in 2022, 17% more expensive than the HMA. And based on presentation from Frank, it seems that the number the difference is higher at this moment. So it's more expensive. If I look at the greenhouse gases emissions of the RHMAG, it's also higher than the greenhouse gases emissions of the HMA, right? If I want to produce 1 ton of RHMAG, I'm going to emit in the order of 35% more greenhouse gases that I would emit when producing the regular HMA. So the question is, why do we need RHMAG? And the answer, as you have heard before, is that the performance of the RHMAG is much better than the performance of the HMA in many aspects: noise reduction, microsurface, microtexture, but cracking resistance is one of them. The cracking resistance of the RHMAG is way better than the cracking resistance of the regular HMA. What you see in the screen is something that we call the ideal cracking test. That test has become very popular during the last year. And the idea of that test is that you take an asphalt specimen, you put it in that frame, and then you push and break the specimen. And while you are pushing, you are registering the load and the displacement. So this is a test where you can see what is the maximum strength, or what is the strength on the material, and also what is the displacement that I have to apply in order to break the specimen. You see that the HMA reaches the peak and it goes down very quickly. That's something that we may say this is kind of brittle behavior. The RHMAG in black, you see that after the failure, the specimen continues holding the load. That's because the RHMAG is much more flexible. It has higher ductility. It has a higher capacity to be stretched without failing, right? That's the idea. I can take the RHMAG and stretch it much more than I can do with the HMA. And that's a very important parameter. There is a cracking parameter that is becoming very popular that is called the CT index. That is basically measuring that. It's measuring how much I can stretch my mix before failure. And these are some examples. You see on the left in gray, the sample for a number of mixes that we have been testing during the last year. I just took the recent mixes, and in black, a number of RHMAG mixes that we have been testing during the last year. The base binder is the same in all of them. All of them have more or less the same base binder. But if you see the CT index, that is what is giving us some idea of the cracking resistance of the mix, is so much higher in the RHMAG than in the HMA, much, much higher. And why is this important? This is important because the US is moving in a direction where the asphalt specifications that used to be recipe-based, empirical specifications, are moving to performance-related specifications. So in the short future, and seems that this is going to be happening, the idea is that the agency will not be telling the recipe. The agencies will be telling the contractor, I want your mix to perform, to pass this test. Now imagine a scenario where you are asking the mix to pass a CT index of 100. There's no way you can do that with the HMA. You can do that with the RHMAG. So from my point of view, the performance-related specifications framework, that's going to be a game changer for the rubber product and for similar products that help improve the fatigue resistance of the mix. 4-point bending fatigue resistance. I like this test very much because it's a test that has been shown to have a very strong correlation with the field. And when we are doing designs with CalMe is the tool that we use to do mechanistic empirical pavement design in California for Caltrans. When we are doing the design with CalMe, this is all about this test. That test is one of the main inputs to that software. So what is the idea of this test? In this test, you take a beam of material, okay? You have to build a slab, cut the beam, and then you take the beam and you start to bend the beam up and down, up and down, up and down, many times, hundreds of thousands of times or millions of times. And that's what you see on the left picture. So what you are measuring during the test is the stiffness degradation of the beam. At the beginning, and that's the plot that you see, the beam stiffness is 100% the initial stiffness, but as the test continues, the stiffness goes down. And it goes down up to a point that you see in red in the picture, which is when you see the cracking, right? So the samples that you see there is just an example of two mixes tested at the same strength, one HMA and one HMAG. The HMA failed in a few 100,000 repetitions. The RHMAG resisted for more than 3 million. And that difference is real. I mean, we see that in the laboratory all the time. Again, when it comes to resisting fatigue cracking, the RHMAG has a way better performance than the HMA. And again, when that was one example for just two mixes, I took the collection of mixes that I showed before. Those are mixes that we have been testing in the last year. If I subject those mixes to 400 microstrains, 400 microstrains is the typical deformation that you may have in a pavement that is relatively thin on top of something that is in relatively bad condition. So it's relatively high deformation. What you see is that the HMA mixes last for less than 1 million cycles. The RHMAG mixes go at the minimum 2 million cycles, and some of them get out of the scale. Again, when it comes to fatigue cracking, the RHMAG is like one order of magnitude above the regular HMA. There have been plenty of studies in the field, in the lab. Some of the initial studies was a reflective cracking evaluation with the heavy vehicle simulator that showed that in terms of reflective cracking, 1 inch of RHMAG is equivalent to 2 inches of regular HMA. So again, my main message with this long introduction that has been 11 minutes is when you compare HMA versus RHMAG, don't think like 1 ton versus 1 ton. That's not the fair comparison, okay? The RHMAG is going to perform much better than the HMA. Now, let's go to the background of this presentation, the reason why we started this study, the study that is use of RAP in RHMAG. At this moment, the Caltrans specifications do not allow the contractor to use RAP in the RHMAG mixes, okay? And that's something that happens in many countries when it comes to the surface layers. So again, you use RHMAG in the surface, you expect that mix to have a very high fatigue performance, so you don't want to, the original idea is let's not add RAP because we are scared of the RAP reducing the fatigue performance. On the other side, the idea is, well, why not adding RAP, right? What are the advantages of adding RAP to the RHMAG? There are two main advantages. One is the economy, okay? The material will be cheaper, and the other one is the environment. You are reducing the need for extracting new aggregates, you are recycling the old binder, and so on. So there are economic and environmental reasons to think about the idea of adding RAP to the RHMAG. The question is it worth it? If I add it, what is going to be the performance? So that is the goal of this study. Then what we did is, or what the PMPC group decided is, they will launch a number of pilot projects. So there have been 5 pilot projects in California that you see the location there. If we had more time, we would talk about the idea of having pilot projects in the Inland Valley and even in the high mountains, right, where at this moment the use of RHMAG is almost zero. But those are the pilot projects that we have evaluated. And what we do in a pilot project? So this is one example of one of the pilot projects. What you see there is the picture. There is this pilot project where I think it was like 10 miles or something like that. I don't remember exactly. But in all the pilot project, this is about a mill and fill operation. In almost all of the pilot project, the contractor used a regular RHMAG. That means an RHMAG that has no wrap. Then in a small section that was 0.4 miles, the contractor used an RHMAG with 10% wrap. So what we do? We go there, we monitor the construction to make sure that there is no problem with the compactability of the mixes, and then we sample the mixes, we bring the mixes to the laboratory, and then we do a very comprehensive laboratory evaluation of the mixes. In addition to that, we monitor the performance of the pilot at least during 5 years. Okay, that's the idea. We have finished the testing of the mixes, so we have the preliminary conclusions. Based on that conclusion, we were able to make a recommendation, but again, we still need to monitor the performance of this during 5 years at least to see that everything is going well. I think now relatively, still have 5 minutes, right, Lito? Okay, so just one comment. Again, coming back to the gap gradation, adding wrap to the RHMAG presents some challenges, right? What you see in gray there is the typical gradation of the wrap. The wrap typically has a continuous gradation, but what you see in red that's the specification limits that Caltrans is applying to the RHMAG, which is a gap gradation. So I cannot add as much wrap as I want, because that would be incompatible with the original gradation, right? So there are some challenges there. That's why in this project, the amount of wrap that they added is 10%. It seems that the maximum amount of wrap, I would say that is going to be in the order of 20%. It seems difficult that you could go beyond 20% wrap without making additional changes. And the other comment is, in this project, the contractor chose a relatively simple approach to add the wrap. Okay? They didn't change the mix design. What they basically did is, in order to add the wrap, they tweak the percentages of the different bins during the production to match the original gradation. So basically, they replicated the gradation of the control mix. In most cases, they considered that the binder in the wrap was contributing to the minimum 7.5%. So let me clarify that for this type of mixes, Caltrans is requiring a minimum of 7.5% of binder content. So the question is, when you are adding the wrap, the question may be, well, the wrap has binder. Does that binder contribute to the 7.5% or not? Right? That's a question that's a question that we try to address also during this study, because most of the contractors opted for the option that you see in the middle, right? Which is basically that the wrap is actually contributing to the minimum 7.5%, but a couple of contractors opted for the other option, where they added the wrap binder on top of the 7.5%. Then, again, we sampled the mixes. We conducted a very comprehensive laboratory testing to study many different aspects. And then this is the result that we obtained. Again, the goal was, let me repeat the goal, and I'm reading the slide literally, the goal is to evaluate how the addition of 10% wrap by aggregate replacement impacts the properties and expected field performance of the RHMAG. And we achieved the goal by answering 4 questions that I'm going to be formulating now. I'm going to be finishing very quickly. So first, how do the mechanical properties of the RHMAG change when we add the 10% wrap? That's the main question that we want to see. And the short answer is the change in the mechanical properties was negligible. Okay? Differences from one project to another project were much bigger than the differences that we observed after adding the wrap. In some cases, we saw a small drop in the fatigue resistance, but in most cases, we saw that there was no drop or even an improvement in the fatigue resistance of the mixes. So from the mechanical properties point of view, we didn't see any problem with adding 10% wrap. We did some modeling, and don't look at the picture because it's probably confusing. We did some modeling with Calmi. right? CalMe is the software that I was mentioning before that is used for mechanistic empirical designs of pavement in California. And the question with CalMe is, we fitted CalMe with the properties of the control mixes with no wrap, and then we fitted CalMe with the properties of the test mixes that had 10% wrap. And then we did the pavement designs in different scenarios. And the outcome was that it doesn't matter. So we get the same thickness with the two materials. So again, based on CalMe modeling, the two materials are equivalent. In other words, there is no problem with adding 10% wrap to the RHMAG. We also did some evaluation of the different approaches that the contractors use to add the 10% wrap, and we are very happy with the outcome. We believe that the contractors followed or the HMA producer, the mix producer, followed the right approach to introduce the 10% wrap. And regarding the binder contribution to the minimum 7.5%, our conclusions was that there is no problem with assuming that the binder in the wrap is going to be contributing to the 7.5%. So basically, the original mix, if in the original mix you have around 6% virgin binder, in the mix with wrap, you're going to have in the order of 5.5%. And again, the final question is, how do cradle to gate global warming potential change? And what you see there is a pie chart with the emissions of the production of the mixes. You have A1, A2, A3, which are the information models in the ISO 21930. And the A1 is the energy, the greenhouse gases emissions associated to the production of the raw materials. A2 is the transport, and A3 is the operations at the plant. This is just one example, but you see that a considerable part of the pie chart is the asphalt binder production, right? So because we are accounting for the binder in the wrap, we are reducing the need for virgin binder in the production of the RHMAG, and that has a positive impact in the global warming potential. That means that when we add a 10% wrap, the greenhouse gases emission, the saving in greenhouse gases was 5%. So we reduce it in 5% the global warming potential of the RHMAG mix. And in summary, the conclusion is, and I'm reading the conclusions from the slide, is first one is the additional 10% wrap had minor effects on the mechanical properties of the RHMAG. Overall, the effect of the wrap addition was negligible compared to project differences. Second conclusion is, from the constructability point of view, the addition of the 10% wrap did not create any problems. Third conclusion is that the impact of the 10% wrap addition on the cracking performance of the pavement based on CalMe modeling was either negligible or comparable to project differences. Fourth conclusion is that the positive outcomes from the 5 pilot projects support the steps that the contractor follow to add the 10% wrap. And final conclusion is the addition of the 10% wrap to the RHMAG resulted in global warming potential savings of 5%. And with that, I conclude my presentation. Thank you.
Thank you so much, Angel. Very good information.
Very cool.
Questions?
Steve Castle, CRM. Not so much a question, a great presentation on how, and very informative. I guess just more of a statement. Caltrans, as you guys have documented, has a mandate to utilize roughly 35% rubber in their overall hot mix tonnage. That's Caltrans' mandate. There's no mandate currently for city or county agencies. Is that something that, that seems like something that would be worthwhile pursuing on the city-county side as we have it in place at the statewide highways side?
Well, that's a hard question, right? Maybe that's something also for Brandon Miller, Calapa here to address. Yes and no. I mean, the no that I would say is because I really believe that just by relying on the mechanical properties of the mix with rubber, we can push the market. That's the reason why I would say no. I think there's plenty of work to do in terms of training the cities and counties people, pushing them to use the rubber, make sure that the first pilots are highly monitored so that it is a success. And once they are comfortable with that, they will be using more. So from my point of view, as a researcher, we also want that to bring this to a situation where they can use more rubber, even without a mandate. And that's one strategy. There is another strategy that is related to the presentation that here my colleagues did, is other technologies to use the rubber, right? Which is not only the wet process that we use in the RHMAG. So at least I feel that there are plenty of tools at this moment to make the use of rubber attractive and competitive, even without any mandate. That said, Brandon from Calapa, maybe you wanna make an additional comment there.
Thank you, Angel. Okay, Angel, you pretty much hit it. I think for us, as an association, we do not support these full mandates, what we see here on Caltrans, the legislative route to make something happen like that by mandating it. We believe that it's really about the performance and the engineering merits, and that the use of that we want to ensure that the right products are used in the right situations, and they're engineered properly. And so really what I think when we look at the opportunities in the public workspace and our roadway infrastructure to increase the use of tires, it's really about what are the different ways that we can incorporate that crumb rubber into our mixes. What are the ways that we can ensure that we can use crumb rubber modified materials in our mixes, whether it's for an interstate, a residential road, an airfield, so an airport runway, for liners on water quality, for water reservoirs. That's what we should be focused on, and that's how we're going to increase it, is by finding other ways that meet the performance characteristics of the use of those pavements.
Could I offer one thing too? A lot of public agencies, grant funding is a lifeblood. And so I've seen a lot of public agencies add asphalt rubber into their grant applications as a way to, sweeten the pot, so to speak. So that's a carrot approach.
And I think that's really important and good, especially to draw it back to the premise of the conference as a whole, is how do we recycle more tires? And being that 50% roughly are going to landfill, and we've had only consistent 35% usage of crumb rubber, I agree with you, Brandon, finding more ways and tools and applications of crumb rubber as it relates to paving is ideally what the end goal, especially because paving is by far a better innovative tool for crumb rubber and for tires than other, products and systems and out there.
Yeah, and just one thing, when we look across the country at the use of ground tire rubber in pavements, I think in California, we're really the exception. When you look at all the ground tire rubber in pavements that's used across the country, California probably accounts for 80% of that. So there's a lot of space out there, both in California, but even outside of California, where you can see the performance would be a benefit for the owners of of our roadway infrastructure.
Unfortunately, we have to cut it off here.
Yeah.
Oop. Yeah, wrapping it up. Yeah, big hand for everybody here. Round of applause. And also to all that stayed here.
Go into
Hey, you guys. Yeah, wonderful panel. Gold Star to Lido, making it through all of these people in that amount of time, so appreciate it. I just have a few closing comments. I recognize I'm the only person in between you and the doors are back there. So I'll do my best here. I just want to acknowledge that we had 40 presenters, approximately 40 presenters with a ton of content. some moderators really adding to that, and then the rest of you either here in the room or virtually, adding to the questions that you're asking and the interactions throughout the course of the conference. And I just want to give you guys a big round of applause. You're welcome to join me. I specifically want to call out Olivier for a keynote and Michelin for providing that. I appreciate you guys being here through the entire conference and providing that information. And to our exhibitors, too, appreciate you guys being here and hopefully made some good connections through this. I will recognize there's a lot of work that's been done to get to this point in the tire world. There's a heck of a lot more work to be done, I can tell from the discussions that we've had here. I think this is the group to do it. And I was really excited that this has been extended to an international audience too. We had a number of international attendees, and this is a worldwide challenge. So I think what we're doing here in California is profound, and your work is what's doing that. So I just want to extend that thank you directly to all of you for that. A few things to mention, and I know Zoe, our director at the beginning, acknowledged this, but the Tire Conference Committee, I really appreciate all of you that helped plan this content. You know who you are, Psychic Income there. I'm not going to name you again, but I do want to just mention how important that is. I think the content was meaningful, and I hope you guys did too. And sort of to test that out, we do have a survey that'll be available that will be sent out post-conference. So I encourage you to be true and authentic in that, kind as well. But give us your feedback. If there's content that we're missing, say for future conferences, we'd like to know about it. Or did we hit the mark? What do we need to add? Also want to thank again our interpreters. The amount of words interpreted in this conference had to be profound. And call out to Translang, and also for Lulu from Public Affairs helping coordinate that and the headsets. Russ, thanks. Yeah, thank you. You guys choose when to clap. Russ, thanks for the timekeeping. Really appreciate that. Kept us on track. And also to CalRecycle's IT team, also to Metro Media for their work in getting this filmed, recorded, all the sound in the right place. So very much appreciate that. Let's give them a round. I want to thank the Holiday Inn for the food. Fantastic food. I know it takes a lot of work to do that. And then a special shout out to Sac State, Tommy as a lead for their team. We couldn't do this without him and that team, so very much appreciated. And again, encourage you on the post-conference survey. And really, I think that's all I had to say other than thank you for being here. We'll see you next time and travel safely. Thank you.